This video is going to cover the 5-3 warm-up and then the notes for 5-4. So we start with the inverse functions to find all the solutions of the equation on the interval of 0 to 2 pi. And that should be a bracket on the 0 and a parentheses on the 2 pi. So we're saying include the 0, but don't include the 2 pi. Go up to that point. So if you look at the first one, this is tangent of 3x times tangent of x minus 1 equals 0. It's already factored for you. So you're going to split those into the two parts. I would say that the tangent of 3x equals 0 and the tangent of x minus 1 equals 0. And then on the left-hand side, if there was a 3 in the front, I would divide both sides by the 3. But because the 3 is in the middle, I'm actually looking for where where tangent is 0, which is going to happen at 0. If I go to where the angle is 0 degrees, 0 over 1 would be 0. And it's also going to happen at pi because 0 over negative 1 is also 0. So the two answers for tangent of 0 would be 0 and pi. But we have a 3x, so that 3x gets set equal to 0 and the 3x gets set equal to pi. And then divide both sides by 3. You end up getting x equals 0 and x equals pi over 3. So because the interval is fixed here, we don't have to worry about adding on any like n pi's, which we'll show you at the end what that would do. So on the other side, I would add the 1, and I would get the tangent of x equals 1. And so I'm looking for where on my unit circle. Tangent is 1, which occurs at the over 4 in the first quadrant and the over 4 in the third quadrant, which would be pi over 4 and 5 pi over 4. And again, we already have a fixed interval, so those 4 would be the answers, and I don't have to add on any of the additional intervals. So when you're listing overall, it would just be x equals 0, pi over 3, and pi over 4. And then 5 pi over 4. Now let's look at number 2. Secant squared x minus secant x equals 2. So hopefully as soon as you see that there's a squared and a non-squared, this means you're going to eventually have to factor this out. So the first thing I want to do is get everything to one side. I'd get secant squared x minus secant of x, and then move the 2 over by subtracting it. And then you can actually like substitute in the a. I can say a equals secant of x. And then I would get a squared minus a minus 2 if it helps you factor it. Or you could just straight factor it from the secants. Square root of secant squared would be secant x and secant x. And then factors of negative 2 that sum to negative 1 would be negative 2 and positive 1. Split those into 2 and set them each equal to 0. And on the left, I would add the 2. I would get secant of x equals 2. And on the right, I would subtract the 1. Secant of x equals negative 1. And because this is secant, which is a reciprocal function, I would flip it. So I'm saying that the cosine would equal the reciprocal of 2, which is 1/2. And the cosine would equal the reciprocal of negative 1, which is still negative 1. So I'm going to actually pull in the unit circle here so that we can get a better look. I'm looking for where around my unit circle, my cosine, which is my x, is a positive 1/2, which is going to occur at that positive pi over 3, and down on the bottom there at 5 pi over 3. And then where cosine is negative 1, or where x is negative 1, would be at pi. So my 3 answers are pi over 3, pi, and 5 pi over 3. So if there was an interval here, I would add on 2n pi, but again, we'll get to that at the end. So number 3 has 2 different trig functions, and hopefully you can identify here that I would have to change these so that they are not the same trig function, or so that they are the same trig function, sorry. So you remember your one of your Pythagorean identities has secant squared and tangent squared in it. That identity is tangent squared plus 1 equals secant squared. So I can either replace the secant squared with the tangent squared plus 1, or I can replace the tangent squared with the secant squared minus 1. But we're going to go with the first one this time. Again, it doesn't matter, but I'm going to replace the first one with tangent squared plus 1. And then plus tangent squared x minus 3. distribute the 2 into both the tangent squared and the 2. And then from here, I want to combine my like terms. I have 2 tangent squared, so 2 tangent squared plus tangent squared becomes 3 tangent squared x. And then positive 2 minus 3 is negative 1 equals 0. I'm going to add the 1 to the other side and then divide both sides by 3. So the squared on the inside, when I go to square root it, I'm square rooting the function, but of course you have to do the plus and minus. So I'm looking for where the tangent of x equals plus and minus the square root of 1, which is 1, over the square root of 3, and that gets rationalized to square root 3 over 3. And again, hopefully you remember from the inverse trig function section that the root 3 over 3 is your over 6 angles, because 2 3's make a 6. So we're talking about positive and negative, which means every over 6. This would be your pi over 6. This would be your 5 pi over 6, your 7 pi over 6, and your 11 pi over 6. So all 4 of those angles would be your answers. And again, we're on a fixed interval this time, so I don't have to worry about adding anything. If I wasn't, I would add n pi. So let's look at what that would be like if instead of it being on this interval, it actually didn't say from 0 to 2 pi. For sine and cosine, you want to remember that we would add 2n pi or 2 pi k, 2 pi n, either of that's all the same thing. That means that that answer repeats every once around the circle. And then for tangent and cotangent, and then with sine and cosine obviously would be its reciprocal functions. But for tangent and cotangent, you would add just n pi or pi n or pi k. So the n and the k just represent a constant. Some books use n, some books use k, some standardized tests use n, some use k. That doesn't matter. They are interchangeable. So for just sine, cosine, tangent, cotangent, we would add the typical n pi or 2n pi. But when you're dealing with a multiple angle like tangent of 3x, you also have to divide the interval by that 3. So if I were to go back to before we divided by 3 and I didn't have an interval, my answer would have been 3x equals 0 plus n pi and 3x equals pi plus n pi or k pi. So then I'd have to divide each of these by 3. And so my 0 gets the 3, but so does my interval. So it would be pi over 3 times n. And then over here, I would get pi over 3 plus pi over 3n. So when you don't have a restricted interval, it does impact what you would add to your interval. Again, the answer on the initial warm-up was not this because we actually restricted the interval from 0 to 2 pi. But if that hadn't happened, then we would have had to do it like this. All right, so this is now Chapter 5, Section 4 notes, which is sum and difference formulas. So we use sum and difference to find the value or exact value of angles that are not on your unit circle. These first two are the sine formulas. So they're in the pattern of sine, cosine, cosine, sine. The good thing is these are a pattern and they're easy to remember. The bad news is you have to remember them all. And with sine, whatever sign, positive or negative, is in my initial problem carries over. So if I'm adding two angles, then I would do sine of the first, cosine of the second, plus cosine of the first, sine of the second. And if I was subtracting, I would then subtract them from the second part. So it would be sine, cosine, minus cosine, sine. Cosine's pattern is cosine, cosine, sine, sine. So whether it's addition or subtraction, it doesn't matter. You do both cosines first and both sines second. The difference this time is you change the addition and subtraction sign. So where if I'm adding in the beginning, I would then be subtracting if I expand. And if I'm subtracting in the beginning, I would then add when I expand. And then tangent, is the same sign in the top. So you would do the tangent of the first angle plus the tangent of the second angle over 1 minus, so it's always the opposite sign in the bottom, 1 minus the product of those two. So if it was tangent of u minus v, then I would do tangent of u minus tangent of v. So again, the sign stays the same in the top, over 1 plus tangent u times tangent v. Okay, so example 1 says find the exact value of each expression. So again, if I had thought about before it's separated, this question would have said the cosine of 165, and it asked you to find the exact value. Well, that's not an angle that's not on your that's on your unit circle, so you wouldn't have been able to find the exact value there. So we break it apart into two angles that are on your unit circle and use your sum and difference formulas. So this would be cosine. Pattern is cosine, cosine, sine, sine. And we change the sign in the middle. So I would do cosine of 120 times the cosine of 45 minus the sine of 120 times the sine of 45. And then we would go to our unit circle. So I'm going to pull one in so we can have it right in front of us. And I would look at the angle that's at 45 and 120. Hopefully we know the 45 one. That should be easy. But at 120, our cosine is negative 1/2. So in place of cosine 120, I write negative 1/2. Our cosine at 45 is root 2 over 2. Minus the sine of 120, which is root 3 over 2. Times the sine of 45, which is root 2 over 2. So then I multiply out my numerators. Negative 1 times root 2 is root 2. And negative root 3 times root 2 is root 6. Both of them goes over 4. And since they're both over 4, I can combine them into one fraction. Negative root 2 minus root 6 over 4. Okay, now we're going to do the same thing with sine. So the pattern with sine is sine, cosine, cosine, sine. So it's sine of the first one, which is 7 pi over 3, times the cosine of the second one. Keep the sign the same, so it's minus. Cosine of the first one times the sine of the second one. And then 7 pi over 3 is actually not on my unit circle. So I would convert that into a mixed number, which is 2 and 1/3 pi. So 2 goes all the way around your unit circle. And then I would go to 1/3 past it, which is that first over 3. That point is 1/2 and root 3 over 2. So the sine there is root 3 over 2. And the cosine at pi over 3 is the same point. And this time it's the x, which would be 1/2. Minus the cosine at 7 pi over 3, which is 1/2, times the sine at 7 pi over 3, which is root 3 over 2. When you multiply those out, you get root 3 over 4 minus root 3 over 4. And these actually cancel, giving you 0. So if you had actually caught it from the beginning, 7 pi over 3 minus pi over 3 can actually be simplified to 6 pi over 3. And 6 pi over 3 is the same thing as 2 pi. And the sine at 2 pi is 0 because it's the y-coordinate at 2 pi. So typically, especially on your test, I'm not going to give you one that can be simplified that easy, but it is definitely something that you can catch that would make it a little bit easier to solve a question like that. All right, example 2 takes you one step further. So this time it says find the exact value of sine, cosine, and tangent of the angle by using the sum or difference formula. And these are not already sum and differences. So we have to figure out what two angles would add up to or subtract to give me 105 or 285, which we'll do in the second one. So hopefully you realize if there's a 5 in it, it means there's got to be one of my 45 angles. If I were to subtract 45 from 105, I get 60, which is also a unit circle angle. So I can write 105 as the sum of 60 and 45. There's definitely more than one way to do this. You could have done 135 minus 30. Okay, but this is just one way to do it. So 45 plus 60 would be the sum I'm going to use. And I'm going to first find the sine of 45 plus 60. So pattern for sine, sine, cosine, cosine, sine. Sine of 45 times the cosine of 60 plus the cosine of 45 times the sine of 60. Hopefully 45 and 60 are ones we're pretty familiar with. Sine at 45 is root 2 over 2. Cosine of 60, or the point at 60 is 1/2 and root 3 over 2. So the cosine would be root 3 over 2. Cosine at 45 is root 2 over 2. And the sine at 60 is root 3 over 2. Multiply them out, root 2 over 4 plus root 6 over 4. And then combine it into one fraction. Root 2 plus root 6 over 4. That's sine. Now we're going to do cosine. And the pattern for cosine is cosine, cosine, sine, sine. So cosine of 45 times the cosine of 60. Change your sign so that it's minus sine of 45 times the sine of 60. Cosine of 45 is root 2 over 2. Cosine of 60 is 1/2. Minus sine of 45 root 2 over 2. And sine of 60 root 3 over 2. Multiply it out. Root 2 over 4 minus root 6 over 4. And root 2 minus root 6 all over 4. That's the cosine. All right, last one for this question is tangent. So I'm doing tangent of 45 plus 60. The pattern for tangent would be tangent 45 plus, so the sign stays the same, tangent 60, over 1 minus, sign's opposite, tangent of 45 times the tangent of 60. So again, hopefully you remember your unit circle angles. The tangent of 45 is 1, and the tangent of 60, because that would be your over 3, is root 3. So 1 plus root 3 over 1 minus 1 times root 3. And I get 1 plus root 3 over 1 minus root 3, which cannot stay there because it's irrational. It has to get rationalized by multiplying both the top and the bottom by the conjugate. So I would multiply both the top and the bottom by 1 plus root 3. So in my numerator, 1 times 1 is 1. 1 times root 3 is root 3. Root 3 times 1 is root 3. And root 3 times root 3 is just 3. Combine my like terms, I get 4 plus 2 root 3. The denominator would be 1 plus root 3 minus root 3 minus root 3 times root 3, which is 3. The positive and negative root 3's cancel. 1 minus 3 is negative 2. You can also use your shortcut there, which is a squared minus b squared. The negative 2 goes into both the 4 and the 2. So I can either write it as 2 plus root 3 over negative 1, or take it one step further to simplify it, making it negative 2 minus root 3. And that's as simplified as it gets. All right, B. So again, now we've got to come up with two angles that add or subtract to give me 285. And again, there's a 5 in there. If I subtracted out 45, I'd have 240, which is on my unit circle. So I can make that the sum of 245 and 45. And again, order doesn't matter here because that can get switched around. So 45 is my root 2 over 2 angle in the first quadrant. And 240 is the last angle before I hit 270 on the bottom, which means it's my over 3 angle, which is 1/2 and root 3 over 2. And in that third quadrant, they are both negative. Those reference angles or angles are 4 pi over 3 and pi over 4. Pattern for sine would be sine, cosine, cosine, sine. So it's sine of the first, sine of 240 times the cosine of 45. Plus the cosine of 240 times the sine of 45. So sine of 240 is negative root 3 over 2. Cosine of 45 is root 2 over 2. Plus cosine of 240, which is negative 1/2, times the sine of 45, which is root 2 over 2. And you get negative root 6 over 4 minus root 2 over 4. And I get negative root 6 over 2 over, or sorry, negative root 6 minus root 2 over 4. And again, if the order had switched, those two would have just switched. It would have been negative root 2 minus root 6, but it's still correct. Cosine is next. Pattern for cosine is cosine, cosine, sine, sine. So cosine of the first, cosine of the second. Change the sign so it's subtraction. Sine of the first times sine of the second. Cosine of 240 is negative 1/2. Cosine of 45 is root 2 over 2. Minus sine of 240 is negative root 3 over 2. And sine of 45 is root 2 over 2. I get negative root 2 over 4 minus a negative, which becomes positive, root 6 over 4. So I get negative root 2 plus root 6 all over 4. And the last one is tangent. So the pattern for tangent is keep the sign in the top. So this would be tangent of 240 plus tangent of 45 over 1 minus, change the sign, tangent 240 times tangent 45. At pi over 4, my tangent is 1. And at 4 pi over 3, my tangent is root 3. And it's a positive root 3. So I end up with root 3 plus 1 over 1 minus root 3 times 1. I get root 3 plus 1 over 1 minus root 3. And then rationalize it by multiplying both the top and the bottom by 1 plus root 3. My numerator is root 3 plus 3 plus 1 plus root 3, or 2 root 3 plus 4. And the denominator, I can use that shortcut, 1 squared minus root 3 squared, or 1 minus 3, which is negative 2. And then again, it gets simplified, negative root 3 minus 2. All right, example 3. The good news is it gets easier. So this time we're flip-flopping. We're given the expanded form, and we want to figure out which pattern it is and what to do with the value of the angles, add them or subtract them. So when you look at the first one, cosine, cosine, sine, sine, that pattern is cosine. And I know with cosine, I do the opposite of what's in the middle. So with cosine, we change the sign of what's in the middle from positive to negative or negative to positive. This is negative, which means we're going to add 25 and 15. From there, I get the cosine of 40. And for right now, that's all we're doing. So you're just finding what it would be. In the next example, you'll see we take it a step further. Part B, obviously, is tangent. And with tangent, we keep the sign the same. So this is tangent of 2x plus x, which becomes tangent of 3x. All right, so example 4 leads us into finding the exact expression. And in order to find the exact expression, we're going to write it like we just did as one function. And then it will be an angle that's on my unit circle. And I'll use the unit circle to find the exact value. So example 4 says, find the exact value of the expression. A is sine, cosine, cosine, sine. That pattern is sine. So you keep the sign in the middle. This would be sine of 330 minus 30, which is the sine of 300 degrees. And then I'll bring in the unit circle again so we can look at sine of 300 degrees, locate 300 degrees, which is there in the fourth quadrant, and the sign there is negative root 3 over 2. So that's the answer we're looking for. For B, obviously tangent, and for tangent we keep the sign in the top. So this is tangent of 25 plus 110, or the tangent of 135. 135 is in my second quadrant. It's my over 4 angle there, which means the tangent would be 1, and one's positive, one's negative, so it is a negative 1. All right, so example 5 switches gears. Now we're talking about triangles. So these values are not on my unit circle anymore. It says, suppose that cosine of theta is negative 3/5 for a quadrant 2 angle, and cosine of beta is 12/13 for a quadrant 1 angle. Find the exact value of each of the following. So we've got to set up a triangle, and actually there's two here. There's one for theta, and there's one for beta. So I'm going to draw out my first triangle for theta. Put theta in the corner. Cosine is adjacent over hypotenuse, which is 3/5. And the 3 gets the negative because obviously the hypotenuse is still positive, but also because it's in the second quadrant, which means we're moving to the left and up, which tells me that the missing side, which I know to be 4, stays a positive 4. Then I go to beta, draw another triangle, put beta in the corner. Cosine again, adjacent over hypotenuse, so the 12 is there and the 13 is the hypotenuse. And it's a missing side of 5. This time we're in the first quadrant, which means they all stay positive. So the first thing I'm looking for is the sine of theta. So I reference the theta triangle. Sine is the opposite side over the hypotenuse, which would be 4/5. Then sine of beta. Now I'm going to the next triangle. Again, sine, which is opposite over hypotenuse. In this case, it would be 5/13. And then C and D are both sums, which means we've got to expand it out. C is sine theta plus beta. So the sine pattern is sine, cosine, cosine, sine. I do the sine of the first, cosine of the second, keep the positive negative, cosine of the first, sine of the second. And then sine of theta we just found to be 4/5. Cosine of beta was given to us, that's the 12/13. Plus the cosine of theta, which is negative 3/5. And the sine of beta, which is 5/13. Multiply those pairs out, and I get 48/65 plus a negative, so that's a minus. 3 times 5 are 15/65. They both have the same denominator, so I do 48 minus 15, and I get 33/65. And now I go to D, which is the cosine. So cosine's pattern is cosine, cosine, sine, sine, and change the positive or negative sign. So it's cosine of the first, cosine of the second, minus sine of the first, sine of the second. Cosine of theta is negative 3/5. Cosine of beta is 12/13. Minus sine of theta, which is 4/5, times sine of beta, which is 5/13. Multiply them out. Negative 3 times 12 is negative 36/65. Minus 4 times 5 is 20/65. And I get negative 56/65, which can't be simplified, so that's my answer. Example 6 says, prove the identity. So hopefully you recognize this. This is actually one of your cofunctions. We do know that the sine of pi/2 minus x is the cosine of x, but we're going to use our sum and difference to prove this. So sine of pi/2 minus x is a difference, and it's sine, which the pattern would be sine, cosine, cosine, sine. So I'm going to do sine of pi/2 times the cosine of x minus cosine of pi/2 times the sine of x. Pi/2 is where our 90 is. We know that point there is 0, 1. So the sine would be 1. Cosine of x stays as cosine of x. Minus the cosine of 0, which is 0. Cosine of pi/2, which is 0. And then sine of x, which stays as sine of x. 1 times cosine of x is cosine of x. 0 times sine cancels out, and I get cosine of x equals cosine of x. So we're using sum and difference to prove the identity. For example 7, I have some guest teachers here with me to explain it.
Hi, I'm Chase. And I'm Jack.
So the first thing we're going to do is
find all solutions of the equation in the interval 0 into pi. Pi.
So this one says sine of x plus pi minus sine of x plus 1 equals 0. So hopefully you can see that this is one of your sum problems. If I take the sum of x plus pi and use the sum equation.
And the pattern is sine, cosine, cosine, sine.
So I'd write sine of the first angle, cosine of the second. Keep the sign the same, so it's plus cosine of the first angle, sine of the second, minus sine of x plus 1 equals 0. And then we want to simplify. So we don't know what x is. That stays as sine of x. We do know pi is the point -1, 0, and the cosine there would be -1. So then cosine of x stays as x, and the sine at pi would be 0. So that becomes 0. Minus sine of x plus 1 equals 0.
The sine of x is
Times
-1 is negative sine of x. The cosine of x times 0 is 0.
Then negative sine of x plus 1 equals 0. Combine your negative sine of x with your negative sine of x, and you get -2 sine of x plus 1 equals 0.
Subtract the 1 and divide by -2. For where the sine is half.
On the interval of 0 to 2 pi. We're looking for where pi is, or y, sorry, is positive 1/2, which happens at pi over 6, and also at 5 pi over 6. So those are your two answers, pi over 6 and 5 pi over 6. So you can use this time to start your 5.4 homework, and then remember that the review for your test is also posted if you want to take some time this weekend to review it so you're not cramming it in on Monday. And have a good weekend.